400 kilometres above the Earth, the Chinese space station will be the ultimate high-rise building. What it will have in common with tall buildings is the essential need to provide healthy, breathable air to occupants. As in the International Space Station, the air will be 100% recycled. There's no external make-up air supply, so the recycled air needs high-efficiency filtration to revitalise the stale air. The question has been raised about how people can permanently reside at a height of over 300 metres in a building with no openable windows and a constant artificial environment. Providing the highest quality air to breathe would be a good start. Andy Thomas has spent considerable time in space and in the space station. I met up with him at an air show in Melbourne and asked him about the air in the space station. He said it was acceptable, but had a metallic smell. The very first thing he did after landing back on Earth was to take a deep breath of fresh air. Isn't that what we do when we leave buildings? The generally accepted approach to better air quality is source control, dilution ventilation, and air cleaning. Source control is a good first approach in choosing materials that will with low emissions. Environmental certification schemes have been developed in industry associations that include material emission limits, but these are only guidelines. For example, it's commonly used low VOC and no VOC paints. Well, the US EPA says that no VOC latex paint doesn't necessarily mean no emissions. Colouring tints contain high VOC levels. That's volatile organic compounds. And with low VOC paints, linseed oil is used as a drying agent, and it reacts with ozone, nitrogen oxides that come from motor vehicle emissions and are brought in the fresh air from outside. And these form products which can be irritating to our eyes and nose and throat. This is a very small sample of chemicals in indoor air. Most of them are in building materials, commonly used, that can have a bad effect on our health. There are no regulations on chemical emissions from commonly used building materials, and many of the materials emitting VOCs are in standard use. More than 80,000 new chemicals have been developed since 1950, of which fewer than 500 have been studied in any detail. Focusing on a small group of indoor contaminants that are measured because we can in building rating schemes ignores the thousands of chemicals to which people are exposed on a daily basis. We don't have enough data to predict the toxic effects. Dilution ventilation is a common conventional approach to improve air quality by diluting the contaminants, and it's a better approach in combination with source control. But it assumes that the contaminant concentration in the outdoor air, the fresh air, is lower than the indoor air, which is often not the case. Further complications arise with management of stack effect in tall buildings, requiring complex design and configuration of HVAC systems to control air movement within the building envelope without increasing energy consumption. When outdoor contaminant levels are high, the indoor air actually worsens. Dilution ventilation requires that the system has the capacity for conditioning increased amounts of outdoor air, increases capital and operating costs by as much as 30%, with little appreciable improvement in breathable air quality. Commerzbank Tower in Frankfurt is an outstanding example of a bioclimatic skyscraper creating an innovative, energy-efficient solution while providing better indoor air. The atrium is segmented by glass decks into 4 12-storey spaces with sky gardens as part of the natural ventilation management. Using internal landscapes, the whole building is an environmental filter. Providing high-quality filtration, as in the space station, not only delivers substantial energy and cost savings, but also has a measurable effect on building occupant health and well-being and performance improvement. So, source control good, ventilation better, filtration the best, and we need the combination of the 3 to give us better indoor air quality. But biofiltration systems don't revitalise stale air, and except in special cases, such as operating theatres and IT data centres, don't remove most of the thousands of chemicals to which humans are exposed. The value at risk is the cost of not providing best air quality. The US Centre for Disease Control lists the dangers to health from contaminated indoor air. Building indoor air usually contains some or all of these sources of risk. It's only a matter of degree. Most of us have experienced some of these systems, if not all of them. Occupants of tall buildings understand and appreciate the multiple benefits of gardens and proximity to plants. They also want a high quality of living through pure air and pure water. The quest for energy efficiency, for super energy efficiency, can lead to a dislocation of building occupants from the natural environment, emphasising the necessity to incorporate interior landscapes for building occupants to access a form of the natural environment. The priority must be clean, pollutant-free air to breathe. Energy savings are part of the process, not the end goal. This was the first large interior landscape built within a contemporary commercial building in the United States and is still a landmark in the field. With the limited knowledge at the time of plant performance, the design concept and planting for the 12-storey atrium was largely experimental. With a free exchange of air between the garden and the offices, the temperature never varied more than 2.2 degrees Celsius from 21 degrees Celsius at all times of the day and night, summer and winter. Green walls are increasingly seen as an efficient means of introducing vertical landscapes into atriums and building interiors. This conference has seen the launch of Anthony Wood's book, which moderator mentioned earlier on, Green Walls in High-Rise Buildings, and it's highly recommended. But what if this green wall was also an air filter, a highly efficient air filter? Harnessing natural processes to actively clean the air of pollutants, particulates, volatile organic compounds and bacteria, while delivering clean, pollutant-free, high-quality indoor air and directly protecting building occupant health. The space-saving small footprint allows for maximum lettable floor area while contributing to luxury brand status. So what is it and what does it do? What benefits will it bring? Well, a little background. It's based on National Aeronautics and Space Administration research, and this is Nigel and the space plants. Now, Nigel was a Lockheed engineer who volunteered to spend 15 days in a tightly sealed capsule. He worked at one end with a laptop and an ergonomic bike and somewhere to eat and sleep, while he shared his space with dwarf wheat plants. Now, the interesting thing was that the dwarf wheat plants produced more oxygen Nigel could use, so it had to be vented overboard. But Nigel, with all his activity, didn't produce enough carbon dioxide. So they had to pump carbon dioxide in to keep poor old Nigel alive. So there was an imbalance there. And this is Ronald in the test chambers. Ronald spent 15 years evaluating how plants work, how they remove pollutants, what are the mechanisms, what is the natural processes that we can harness that will bring benefit to us. Just as an example, in this test chamber studies, benzene is a known cause of cancer. It's a product of motor vehicle emissions, and each time we fill our tank at a petrol service station, we breathe in some benzene free of charge. It's part of the BTEX, which is benzene, toluene, ethylbenzene and xylene. These are the four components major components of petrol or gasoline, which becomes part of the exhaust emissions from motor vehicles, and that forms part of the so-called fresh air that we bring into buildings, because bear in mind that the only source of indoor air in buildings is outdoor air, and the outdoor air is inherently polluted if we live in cities. Just going back to that, I mentioned benzene. We tested some plants with benzene, which there is no safe limit for, and we found that going up to 1,000 parts per million, which is an extraordinarily strong concentration, the plants were able to remove all of this benzene within 24 hours. Completely removed, turned to harmless carbon dioxide and water, which is what we exhale. So how does it work? What is it? Well, it's very simple, in fact. It's a vertical hydroponic wall, a green wall, which we've seen many green walls, and you'll see them certainly in Anthony's book. And what we're doing is harnessing the microorganisms associated with the plant roots to break down the pollutants. And I'll demonstrate further on with a case study of how it actually performs. So it's a very simple system. It can be freestanding, it can be incorporated into the air handling system, so the air can either become part of the building's air management, or it can be returned back into the space, the occupied space. So, does it work? Well, this was a very good example. This is one of 5 walls in a two floors of an environmental engineering office in Melbourne, UMLI. And this particular wall in the reception area was very conveniently located, so the exhaust from the wall went through the ceiling plenum into the adjoining boardroom, and if the door was closed on the adjoining boardroom, it actually made an ideal test chamber. So after 2 years of continuous operation, an independent testing company was brought in to evaluate the performance of the wall. What does it do? How good is it? So in general terms, what they found were very low levels of VOCs, at or below the detection limits, and a very low microbial count. In fact, lower than the outside air. And also, they found an overall 13% improvement in productivity of the engineers working in the space. So, bear in mind that 500 micrograms per cubic metre is the standard maximum VOC concentration. This is the ASHRAE one. It's used in LEED and BREEAM and green building and so on. So 500 micrograms per cubic metre is the accepted standard. Well, they measured 337 micrograms in the reception area, which is a fairly high level, and they found that this was actually from cleaning compounds that had just previously been used. So you're aware of the lemon and pine fragrances, limonene and pinene, which are used in cleaning compounds, and these are volatile organic compounds. They may smell nice, but they react with ozone and they can create health issues for us. So they measured 337 micrograms per cubic metre, which is below the 500 standard. When they with a single pass, they measured the concentrations in the boardroom and it had dropped to 22 micrograms per cubic metre. In a single pass, that's a 15 times decrease. So they didn't believe these results. They thought, this is not right. In fact, I know this particular company and I know that they were sceptical about the performance of this green wall biofilter. So they decided to dose a mixture of hexane, toluene and ethanol, and they released that into the air surrounding this biofilter wall and then measured the concentration there and the concentration in the boardroom. Well, bear in mind the 500 micrograms per cubic metre, there was an initial concentration of 3,033 micrograms per cubic metre. But in a single pass, that was reduced to 1,704 micrograms, which was a 45% reduction in a single pass, and is actually 3 times, or over 2.5 times the standard. So there was a dramatic decrease. So we know from a practical test by an independent company that the biofilter, when it's performing, actually works. And I might also mention at this stage that dynamic botanical air filtration is actually endorsed by ASHRAE, which is the American Society of Heating, Refrigeration, Air Conditioning Engineers, and they've actually funded a research project at Syracuse University to get an idea of the performance of a wall of this size. So let's look at the cost perspective of better indoor air, because indoor air quality can positively or negatively affect the value of a building. It affects the landlord-tenant relationship, workers' health and productivity, and building elements and systems. From a building owner's viewpoint, improved indoor air quality could increase the building's capital value by 2.29%, just from the net income from the property, but the capital value could be increased by up to 3.85% if all the benefits from improved indoor air quality are taken into account. That is reduction in ventilation costs added in. From a building manager's viewpoint, a decrease in energy costs of 3 to 5% can be achieved from reduced ventilation. And from a tenant's viewpoint, as salaries plus on-costs are the major office building expense, even small improvements in indoor air quality can have a major effect on operating costs and efficiencies. Productive employees accomplish more, and more output means better value and lower costs. Increased worker performance brings a distinct economic advantage. For example, the savings from a modest 1% increase in performance could be sufficient to offset a 50% increase in energy costs in many buildings. This is a 5-storey double-sided biofilter in Toronto, and dynamic green wall air filtration is a self-regenerating air filter solution. It gives the option of maximum code-compliant fresh air rates while delivering high-quality, clean, fresh air to building occupants at low cost. Good indoor air quality safeguards the health of building occupants and contributes to their comfort, well-being and work performance. Many building services engineers have a distrust of biological systems, how to control and manage them. Our PLEMA system ensures all of the parameters for a successful design, installation and maintenance are addressed. So within these 5 parameters, we cover all of the aspects of plant management from planning, design, installation and maintenance. One of the important parts of those 5 parameters is light, getting the light right for plants. If we get the light right for plants in an indoor environment, we're going to get a healthy performing system. So we need to measure the correct light. Additionally, we've developed automated control systems in conjunction with the HVAC controls and building automation systems company for the biofilter. Control solutions can range from a standalone controller, network direct control, through to a fully integrated building energy management system with a 3D graphics. And the data can be integrated into an existing or a new building energy management system. It's simply a matter of what level of control, integration, monitoring or visual display is required. So our PLEMA system, together with our control and monitoring system, has bridged the gap between biology and engineering. This is how easily a biofilter can be incorporated into any tall building. And with acknowledgement to Steve Jobs, polluted air, green biofilter plants, clean purified air. Polluted air, green biofilter plants, clean purified air. Thank you.